Of
Good.
course, we saw like 5 or 6 fires on the way back, so
Yeah, that's not good. That's not good.
I'm sad.
Yeah.
How's everyone doing? How are you doing?
I'm okay. I'm here.
Daniel, are you ready?
I think I'm ready.
I think you are too.
So I guess we'll see.
We'll see. That's right. So I just want to make sure, does everybody know each other? Most of us do. John, do you know everybody? Do you know Jim Jones?
No, I don't.
Jim, maybe introduce yourself for a minute, and then John.
Hi, I'm Jim Jones. I'm an associate professor in informatics. I specialize in software engineering.
Got it. I'm associate professor at the business school in strategy.
Cool. And sort of the long history, and then I'll give you the word, Daniel. Is that Daniel is a master's student in software engineering, has an interest in games. I think, and I'm trying to get the order right between John and Constance. I think you were doing some work with John first, then also landed talking with Constance, and then somehow ended up in my office.
Yeah.
And
So the normal route.
Yes, exactly. And
yeah, I was kind
amongst
of bouncing around.
Yep, that's right. And then amongst the three of us, we eventually got to a software-focused thesis, but still with a flair of games to it. And to pay homage to the history, I think John and Constance are here, but then also to keep an eye out on the software side, Jim is here as well. And thank you all for making time. And Daniel, this is your master's thesis, so give it a whirl.
All right, let me just start the presentation and then share my screen.
And there's probably kids that you'll see running behind me at times. Just, that's life at the moment.
Okay, can you all see my screen?
Yes.
Awesome. Sorry, give me a moment. All right, so thank you everyone for attending today. I'm still getting a little used to doing these presentations over Zoom, so we'll see how this goes. Today, I'll be talking about CapturEsports, a multiplayer data aggregation tool for facilitating esports research and analysis. CapturEsports is a software tool aimed at helping current game researchers in esports conduct studies and observations. And I'm going to go into detail about the different aspects, design, and features that went into developing this tool. So let's jump right in. So esports, or also known as electronic sports, is a form of competitive sport revolving around video games. And it was only a few years ago where video games were viewed as mere hobbies or pastimes. And the stigma has actually evolved into an industry where playing video games have become full-time professions. And here are 4 examples of what esports are today. So let me get my laser pointer out. So this game is League of Legends. It's a long-running team-based game with tons of global tournaments and leagues. This one is Valorant. This is a newer first-person shooter that is kind of breaking into the scene, and we're seeing these organizations who are starting to create teams around this game that is still kind of in its infancy. And more recently, we have 2 emerging forms of esports, which are based less on skills with the controller and more about bringing real-life sports into a simulation environment. So on the top right, we have sim racing, and below that we have sim cycling. And especially with COVID, we've actually saw professional Formula One racers or NASCAR racers participating in these esports tournaments. And they were participating alongside these amateur racers. So esports has actually become really a fairly large ecosystem and industry. And it's actually fascinating that one aspect of this is the actual gameplay of the game. But another aspect is the viewership and audience surrounding esports. Some of these tournaments have millions of viewers watching the game. And this is a picture from the 2019 League of Legends World Championship. And this was held in Paris, France. And this stadium actually seated, I think, 20,000 people. And they sold out. But online, there was actually over 100 million viewers total. And at a certain point, there was actually 44 million concurrent viewers watching the finals at the same time. With this high viewership, we can see that the growth of esports as an industry. On the left, we can see how this year, esports actually broke $1 billion in revenue. And on the right, we can see the distribution of tournament prize money over the past year. And none of these are small. For a single game, Fortnite, there was a $64 million prize pool, and that's a pretty sizable reward. And so this actually means that there are professional leagues, professional players, dedicated coaches, and organizations that are heavily invested in the success of their players and their teams. So with the growing interest that's surrounding esports, it's also captured the attention of many academic researchers. And so this leads to the types of questions that researchers want to know about this ecosystem. These are questions such as, how do virtual teams approach shared goals? Do they maybe break down the goal into steps, or do they divide up the responsibilities, etc.? We're not sure yet. We also ask questions about how is cognition and temporal information distributed among team players? How do players share information with each other? Who is talking the most? Do they use special jargon? We also have questions about the societal and educational impacts of esports. You know, there's a broad variety of things that people are interested in, whether it's the gameplay or how players think about the game. And we're also interested in things like, how do teams coordinate or explore methods of collaboration? How do teams explore new strategies? What factors of collaboration actually maximizes their success? Among other things, these are only a few of the many questions that current esports researchers are interested in. Our own researchers here at UCI, Jason, Maria, Minnie, JSOC, and working with Constance, they've actually put together a really good overview highlighting much of the current research. But with so many great questions, the difficulty now is, how do we answer them? How would we do that for distributed teams? Or especially, how do we do that for multiple players? One method that we could use is to watch replay videos and code them. Or another is to manually scrape data from APIs, pull it from the web. But all of this actually becomes extremely cumbersome and really, really tiring. And it becomes apparent that our problem is that there's a lack of data capture tools for multiplayer and distributed teams. So this thesis explores another method where we capture detailed data and allow you to build hypotheses around that data. And there are tools that provide individual performance statistics, and there is a commercial tool that actually captures video for teams for review, but the review is based off of their own interpretations and analysis. But there really isn't a solution for capturing raw, unmanipulated data, data that hasn't been aggregated or analyzed yet. So my research has mainly been about providing support for this lack of data capture tools. Considering this problem, here are the types of things that we actually wanted to see in a software. We wanted the software to support data collection of multiple players in the same match, capture granular or raw data. This is kind of like textual data or in-game events at a very high level of detail. We will also want to collect media recordings to match of a match to bridge contextual holes, such as tacit communication or voice chat. The software also needs to synchronize the time across multiple players to output the correct chronological order of events. The software also needs to reduce the amount of noise in our data and minimize the effect we have on the gameplay experience. And the architecture we design also needs to support new updates in games down the road. Since games are consistently updating, we wanted to build an architecture that can scale with the game. We also want to support the storage of non-game generated data, such as biometric information, including heart rate and facial expressions, And we want to provide users with the power to query the data with custom parameters. And these are things like getting all games within 2 dates or between 2 dates. So in my research as a master's student here at UCI, part of my work was articulating the software requirements, but mainly I developed and built CapturEsports as a tool for this particular setting. CapturEsports has a couple of features. The main one is the ability to capture raw in-game data, temporal data actually. And what this is are player kills, in-game events, the items that players purchase, and things like that. CapturEsports also records the audio and video from a player's screen. CapturEsports also synchronizes the timestamps of the collected data amongst all players. Since each player uses a different machine, the time captured for certain data points may actually differ. So we need to synchronize the time across all players so that if 2 players actually press a key at the same time, that will be reflected in our data. And another feature is that CapturEsports runs in a distributed manner. And this means that researchers and participants don't actually have to be located in the same location to run studies. Studies can be conducted remotely. And this is especially useful during COVID. So research studies won't be stuck at a standstill. Currently, there are actually existing tools for games. However, they only present aggregated statistics or post-game analysis. And so existing tools actually lack the ability to collect raw data at this level of detail. And they lack the ability to capture such data under a multiplayer context. So as a proof of concept, we actually scoped CapturEsports to a single game, League of Legends. So League of Legends is a game where 2 teams of 5 players each compete to destroy each other's base. Each team has a structure called a nexus, and the first team to destroy the opponent's nexus wins. But in order to do so, players must destroy the structures along the path to the nexus. And like on traditional sports teams, each player has a specific role. And as the game goes on, players can make their character or champion stronger by buying items, leveling up with gold and experience, gained from killing enemies and monsters. Now there's 2 definitions that will be referenced later on, and they're just definitions that you should keep in mind. And the first is ability, which is a character's unique spell or power. And this can be a special attack or an ability that will heal an ally. And second definition is an objective. An objective is a goal that helps the team win. An example of it is like killing a dragon, which will strengthen a character, or destroying a tower, which will give you gold to like purchase items. And League is controlled using a keyboard and mouse, and what we want to do is collect data from this type of game. So I want to run through a demo of CapturEsports. Let's see if I can get the screen up. Okay. So I'm running 2 instances of CapturEsports here. And as you can see, you're able to log in as a participant or a researcher. So I'm actually going to first log in as a researcher. Whoops. And so right now the researcher can create 2 things, or it can take 2 actions. The first is create and delete a study. Now I've already created a study, but the study code I created is called overwolf test. So if I actually try to create it again, it's going to say that the study already exists. So this is our example study that we're going to use. So once a researcher creates a study, a participant can actually log into that study and join it. So I'll log in as a participant. And the code I just typed in was overwolf test. And it's not case sensitive, so I can write all lowercase and it will still sign in. All right, so, sorry, let me bring that back. So on the participant side, we can actually see there are 3 columns. The first one is a start recording button, and the second one is a data upload button, and the third is a media upload area. And one thing we can notice is at the top, we can see the status of CapturEsports. We can see the study code we just joined, and we can see a player's assigned temporary display ID. And the third thing is we can see the status of League of Legends. Since we're currently logged out of League of Legends, it's showing that League is not found. So I will just quickly log in. And while we're waiting for that to load, let's talk about the 3 columns. Sorry, it keeps disappearing. So the first column is the start recording. And this button tells the researchers that a participant is ready for a study to begin. But no keystrokes or data is actually recorded until a match has begun. So we can actually view the participants of a study from the researcher. So if we enter the study code over Wolf test, we can see that there's actually 2 participants in the study right now. And right now I am display ID 2 as a participant. Now, when the participant presses the start recording button, the researcher can actually see that display ID 2, the participant is ready. So that means that they are ready for the test to begin, or the study to begin. All right, League of Legends is taking a little bit to load. So what actually happens is once they start recording, the participants can play a game. And once that game is over, the researcher will provide them with a match ID. And here, the players can input that match ID and upload that data to that match. And once the data is uploaded, they go to the third step and they upload the screen recording that was recorded, that was saved. And League of Legends is now loading, so you can see the status has changed to welcome Fat Eater, which is my gamer tag. So once a study has actually concluded and all the data is uploaded, one of the best things about CapturEsports is that we can now go to any web browser, so like Google Chrome, and we can actually view our data. So we go to this specific link, and it's going to ask me to log in. So I will log in real quick. And we can see all the studies that we've run so far. Let's try to zoom in here. And since we just signed into Overwolf test, we can click on that. And this would be the match ID number that we actually placed in here. So all the data will be uploaded for this match only. So for this match, we only have data regarding participant with the display ID 1. So we can look at the data that we have on them, and there are 5 files. We have a match timeline, a match summary, key log, an event log, and a video. So if I want to check out the event log, I can click on it, or I can save it and download it. And it shows us all the data that we've collected, and these are all the in-game events that occurred. Now I can actually format it better. It looks a little more clean. So, and this is the event log. So we can see that in the event log, a single entry contains a used ability, and the ability that they used was type 2. We have the local timestamp that was logged by the machine, a synchronized timestamp that we synchronized so that all players are on the same time, and the synced in-game time. So this ability, or this event, occurred at 16 minutes, 30 seconds, and 640 milliseconds. And there's all these other event data. So things like when a turret is destroyed, abilities, player deaths are all recorded here. In the key log, we can actually see that each entry is a keystroke. So keystroke is when a player or a participant presses any key on the keyboard or presses any mouse key. So one entry has the key value. This is just the number indicator of the key. The key's name, so this was the mouse right, the right mouse button. Whether or not the key was a key down or key up, this means the key was pressed down or a key was lifted up. We also have the mouse's X and Y location of when they clicked. And we have the standard local timestamp of the computer, the sync timestamp, and the in-game time. So back in our web browser, we can actually view the video that we just uploaded. So here we see the screen recording, and we can actually just skip through and see what happened during this game from the player's perspective. And another thing that you could do is you can download the data once you access it. All right. So I'll go back to the presentation. So this is exactly how CapturEsports is actually used when conducting a study. Now, one thing I haven't shown you yet is how the data is actually analyzed, and I'm going to do that a little bit later in this talk. All right, so I'm going to dive a little bit deeper into the technical side of CapturEsports and explain the design and architecture of the overall system. So CapturEsports is divided into 3 distinct tiers. We have the database tier, the service tier, and the client tier. Starting with the database tier, we chose to use 2 solutions. The first one is the Apache *DB instance. And the second is the HTTP server. As you saw in the demo, the raw text data is actually stored in *DB, and this actually gives researchers the power to query the data. There is a database schema underneath this, and it's described in the thesis paper if anyone's interested. And I can talk more about it near the end of the presentation, but I won't get too into it now. We also do support the ability to store external data, such as heart rate and webcam recordings inside of *DB. But capturing that type of data is something that we haven't explored too much yet. So in our HTTP server instance, this is where we store our large 300 to 500 megabyte video files and provide access through a browser. Now, the main difference between these two is that *DB allows us to ask questions about the data. For example, what are all the games between 2 dates? How many times was the character picked? Or what are all the games under 30 minutes? And so the combination of both of these solutions actually give researchers the ability to ask specific questions or download all the data to manage it however they want. And moving over to the service tier, our server handles the communication between the client and the database tier using a REST protocol. Its main purpose is to actually handle the user logins, sign up, and inserting data into the database. And one of the key elements of our server is that it's engineered to support 10 players uploading data simultaneously. And actually a major aspect of this is that I incorporated a library called Resumable, where data is actually uploaded in chunks. And what this means is that if a participant suddenly loses internet connection and it drops halfway through uploading a really large 500 megabyte video file, the file can actually resume uploading once the connection is back. And so the file doesn't have to start uploading from the beginning again. And finally, we have our client tier. And this is actually what we just saw in the demo. There's a separate interface for participants and researchers. And this tier is the one that actually performs data collection. Right here, the game-specific module is what allows us to collect data. And it's built on a platform called Overwolf. Overwolf is a software development kit that actually provides hooks into League of Legends. And that allows us to easily capture events that occur within the game. And in addition to collecting data, the client tier is most responsible for synchronizing the timestamps for each player's data. Based on an internal event in League of Legends that actually occurs at the same time every single match, we can use that time and make sure that time is synced across all 10 players. So I kind of described the design and architecture, but I want to talk a little bit about the preliminary evaluation that we did for this work. And it consisted of two parts. The first was running an alpha test, where we looked at the feasibility, which in short means, does CapturEsports actually work? And does it actually capture the correct data? Now, the second part is, from our data, I did a little bit of work to show how a researcher or a user might perform analysis. So our alpha test was conducted to simulate running CapturEsports in an actual study setting. We recruited 10 volunteers from our own game researchers and played 2 matches. Each match lasted roughly 30 to 40 minutes, and players were all located in their own homes. And throughout the session, we captured keystrokes, in-game events, screen recordings, and voice communication for each player. We also used Discord as our main method of voice communication, and CapturEsports was able to record the audio along with the screen recording. And at the end of each match, all of the data for all 10 players was uploaded within 15 minutes. And using the data that we collected from our alpha test, we can explore 3 potential scenarios for data analysis. The first one is identifying attributes of how expert and novice players play or how they perform differently. The second scenario is exploring behavioral responses following stressful events. And the third is trying to infer significant moments in the gameplay. And I want to quickly clarify that these are ways in which a researcher may look at or use this data. And I'm not necessarily an expert at performing data analysis, since the topic of this thesis has mainly been focused on data collection rather than the analysis. But these are 3 scenarios where analysis can play out. So first is scenario 1. Suppose, as a researcher, I want to identify differences in how experts and novices play. So I bring together a number of players in which I know their relative rankings in League of Legends. And I want to go about finding which characteristics are different. And there's a lot of different characteristics that we could potentially look at, but sometimes the simplest thing is the clearest indicator. So let's take a look at keystrokes as a potential way to gauge expertise. And I want to reiterate that keystrokes also includes all keyboard presses and all mouse clicks. And we're able to query our *DB instance by using a language called SQL or SQL++. And so we can submit a query like this, and where we observe a single match and count the number of keystrokes and group it by a user's ID. And from our results, I can look at whether or not the first person is actually an expert, and then do the same for the second person. Are they actually an expert? And if I can do this for enough matches, we might find that some correlations might actually exist. And since I know the player's rankings, I can now see who is an expert player and what their keystroke count actually is. Now, what's interesting is, as a researcher, I might not be content with this result. I might say that, keystrokes is too broad of an indicator. I need something more specific. Or I might say, I wonder what are some other ways that I can look at this data. And one thing that you can do is separate out the mouse clicks from the keyboard clicks. So let's go through a second query where we exclude all the mouse clicks from our keystroke count. In this SQL query, we include additional conditions such as only looking at keystrokes before 10 minutes or some other time, indicated in this line. And from the results, what we can see is that the top player has actually now changed. Previously, it was the green player, and now it's the blue player, once we take out the mouse clicks. However, the top 2 players still remain at the top, So keystroke may actually be an indicator of expertise, whether it's novice or actual experienced experts. And the difference between 1118 keystrokes versus 64 at the bottom is pretty drastic. And if it actually turns out that the blue and green players are actually experts, then we can ask why this giant difference exists, and we can actually look further into it. And this is just one way where I can play around with the data and see how I can correlate it with things I already know about the participants. In scenario 2, as a researcher, I want to examine a player's behaviors during a stressful moment. And I may be watching a video replay and I notice that there's actually a fight breaking out around a dragon that had been killed. And since I know this event occurred around 17 minutes and 4 seconds, I want to ask, can I see what happens during this time window? Now, from the query I constructed, I looked at all the players and the use of their abilities 1 minute before and 1 minute after the 17-minute and 4-second mark. And it is just a quick reminder that an ability is when a player activates a spell or power that's unique to their character. And from our results, we can see which player used the most abilities and answer questions like, is there an apparent fight or flight response when a stressful situation is encountered? Are some players paralyzed and completely lost during these moments? Or do some players take charge and fight their way out? Now we can assume that maybe if a player has a high ability usage, maybe they're fighting, using more to fight their way out. Or maybe if the players are using less abilities, they're fleeing from the situation. And we can actually examine this further by taking a closer look at a single player. And here I did something a little differently, and I pulled out the data and put it into a CSV file. And one of the things you can see is that this specific player repeatedly pressed the A button multiple times. And he pressed W and E a couple times, but mainly it's A. And so we want to know, what does this signify? Maybe the player is using an ability many times. Or maybe they're hoping that the game will register the ability faster once the ability becomes available again. Or maybe the player had died and is actually spam pressing a key out of frustration. This would actually need to be examined further, but this allows you to look at what these players are exactly doing to inform how are they engaging with this stressful situation. In scenario 3, I want to first think about any competitive sport. And throughout a match of any sport, there's essentially a constant power struggle between both teams. And at a certain point, there's going to be a moment where one team actually gains the upper hand. So as a researcher, can I, rather than looking at the video, identify these game-changing moments from just the data? So based off of the queries that we actually constructed in scenario 1 and scenario 2, I created additional SQL queries that I'm not showing here, but these queries calculated the average number of abilities used for each team within short time frames. And I specifically looked at the time frame between 2 objectives that were secured. And this is a reminder that an objective is a goal that helps a team destroy an enemy's base, such as killing a dragon or destroying a turret. And here I constructed a table from the query that shows 2 secured objectives, Objective A and Objective B. And starting from when Objective A was secured, I calculated the average number of abilities used in order to secure Objective B. And the reason I did this is because if we realize that teams are using a lot of abilities, that seems to say that they're no longer conserving their abilities. But if they actually use more abilities to win in a certain objective, then they must believe that they can have potentially get an upper hand to win the game after securing this objective. And this is indeed interesting when we look at the second row surrounding the objective Rift Herald. The blue team had actually used 23.2, on average 23.2 abilities. And that's about 50% more than the next highest average that they had. And the red team used 8 abilities, which is still the highest number of abilities from the data that we've looked at. So this means around 13 minutes, securing Rift Herald was actually an important part of the game, and we can now go back to the video and check the outcome. And these are just the beginning queries and ways of looking at the data. And like I mentioned previously, I'm not an expert data analyst, but these are just some thoughts on how how a researcher might query this data. So to sum up everything, in my thesis, I developed and built CapturEsports as a software tool for collecting data from the game League of Legends. I've also contributed a novel infrastructure for data collection, storing the data, and retrieving the data for various research studies. With our alpha test, I verified that CapturEsports works and fulfills the core software requirements that I defined. And finally, I performed a preliminary evaluation to illustrate how a researcher might go about analyzing the data that we collected. In the future, there's still a lot of work that can be done to CapturEsports. From the demo, you may have noticed that there's actually a manual step to upload data, steps 2 and 3 from the participant. But in the future, it may be possible to actually automate these tests, or automate this process, simplifying what participants need to do. We can also investigate creating a domain-specific query interface, making it easier for researchers to ask questions. So like the 3 scenarios I presented, we could explore that without having to create those complicated SQL queries. Another thing that we could further look into is extending the capturing ability by supporting new types of data. Right now, we record a player's screen, and some researchers are also interested in facial expressions or the heart rate of players. So in the future iterations, we could integrate using biometric devices or a webcam to record a player's face. And finally, CapturEsports was designed with the capability to easily add support for other games. While we only support League of Legends at the moment, adding more games will actually allow researchers to explore virtual teams in other contexts. And that's it for my thesis, CapturEsports. Thank you all for listening, and I can take any questions that anyone might have.
Thank you. Yes, right. That's right, Jim. Little applause now. Then we're going to ask questions. And I forgot earlier to welcome the audience as well, because the committee is not the only people on the call. It's typically customary for the committee to ask the first questions, and then if there's time permitting, and there should be time permitting, we'll open it up to questions from the audience as well. So I first want to invite John, Jim, Constance. Any questions? Jim?
So I can, I can ask questions kind of more from the software engineering and design perspective, and I assume that Constance can ask more pertinent questions than I even know, like on how these kinds of tools would need to be used. But I mean, I'm just curious about a couple of the things that you mentioned in here, and I understand the need to do time syncing and finding an event that's shared that everybody was going to be synced on. It's a smart solution. But I wonder, do you have any, have you, okay, first, my preliminary question is, how long do these games tend to last?
So typically the games last roughly from 30 to 50 minutes on average.
Okay. Have you seen any issues with clock drift?
So the only thing that might affect clock drift is the lag in a game. So because it's on a server.
So I'm gonna disagree with that. So the different computers have, you could have a machine that has a slightly weak internal battery, or somehow its clock is running faster than the other players on the team. And so even though you're doing a sync, your times within that window, within a short period of time, are going to be relatively close. But then, as you get further and further away, one of the machines could be running faster or slower, and then your clock, your synced timestamps are going to start to drift apart again.
Mm-hmm.
And I wonder. I mean, I know that, and I say this only from the perspective I've heard people talk about doing syncing of audio tracks that last like an hour long, and that often you do have a drift where one person starts to like talk on top of another person, because as you get further away, like an hour away, that time accumulates and becomes a problem.
Mm-hmm.
So it might be something that needs to be addressed.
Yeah.
Like other events to kind of help synchronize further down the road.
So when we verified the data, we actually didn't see any of that clock drifting. But when we verified the data, we do know that there is like a 1 second ambiguity. So within, I guess, the 1000 milliseconds of when an event occurs, there could be slight changes, but all the data that we looked at landed within that 1 second of the video that we recorded.
Yeah, that makes sense. I think it
Yeah.
would be small amounts that,
Mm-hmm.
that it would drift. It wouldn't be great.
Yeah.
Okay, and then from the perspective of you chose one game and you wrote this engine for that, and I understand that the API that you're using, the Overwatch, is one that's specific to League, right?
So it actually supports many different like competitive esports games.
Okay, so then what would it take to make your tool like if you wanted to say re-architect it or refactor it in future work, obviously, what would it take to refactor your tool so that it could support other games in addition to League?
So I'm actually going to go back to my architecture slide. So actually, if we look at this game-specific module right here, all we need to do is just swap that out with the game that we want. And then maybe we have to adjust a little bit on the server to how the data will be inserted into our database, since different games have like different data structures. But essentially, it'll just take a little bit modification to the server and creating a separate, I guess, module plugin that we can just swap out. And that's essentially how like we would create a new game or support a new game.
Okay, thank you.
Yeah. Any other questions?
Nonsense.
Yeah, well, first, I just want to commend you on your work. I mean, for our lab, this has been just a gift, right? It's been really, really terrific. So I am not a software engineer, so mine will be less technical, but I would like to hear about, what your plan is next and what you hope to do with this tool. What are you thinking about using it for?
So we're actually trying to run a pilots test with like Jason, JSOC, and Gary. So I'm gonna stick around and help out with those because I want to see Capture Esports in action to see like, what it does. And then I can also help out with any of the software issues that might come up. In terms of supporting other games, I'm not sure if I can create, these modules to support games like, Counter-Strike or Dota 2, all the other big competitive games. But hopefully, like, I documented everything very well and created all these diagrams so that maybe potentially for, future undergrad software engineering classes, they could create these like game-specific modules as kind of an academic learning tool and like getting some developing experience in. So hopefully that's something that like could happen.
Well, I think the fact that you've chosen like the most central game of this generation for esports makes this tool really useful for not just our lab, but many labs. And I'm curious as to whether you've thought about how much you want to distribute this tool, how will you regulate access, what are your next steps, and where are you headed next? What do you want?
So that's a good question. I've thought about distributing it kind of open source, but I think there are a lot of privacy issues, especially if we're collecting keystrokes. So we definitely do need like the consent of the participants, and to like make it known that like the data that we collect is very sensitive and can be very sensitive. So I haven't really thought too far about distributing it because of those issues. But hopefully, like, through the right channels, we could get other universities to maybe hop on and use it as well. To provide access to other people, I would probably have to talk to the other researchers about like how we will manage that.
Well, I can name a couple colleagues that would absolutely clamor for your tool. So when you're ready for that, please let me know. I think what you've built is shockingly helpful and solves a lot of strange but really hard to solve problems, timestamp being the most obvious one, but other real difficulties that we run in trying to collect data that actually is around teams. So I'm really grateful for your work. I do have one question, and I'm a little embarrassed to ask it because it may be a naive question, but I know you had talked about, that it supports at least 10 clients connecting and using at the same time, obviously, so you could have two teams competing. Can you explain to me, can you be running simultaneous studies with at least 10 clients in those studies at the same time so that the data sets are partitioned? I don't have a conceptual model for that. So I was just curious about whether that's possible.
So that's not something that we've tested, but the way that it's designed, yes, that should be possible because each study is separated by the study code. So in our demo, in our demo, I used Overwolf test, but the researcher can just put in any random string characters that they want as a code, and then that study will be separated under that code.
And while I have you, here's another little fantasy of mine, and I have no idea what it would mean, but about 5 or 6 years ago, our lab created something called AdEdge, and it was an open source data architecture for folks that were making games for impact so you could collect data. But it also, in order for us to go from keystroke to, evidence, in this case, evidence of learning or behavioral change in the game, we had to add what we were calling like sort of a semantic net, meaning that we had to be able to bundle and cluster those keystrokes into meaningful chunks of activity. And your system is already kind of, you've done so much work to do that. I wonder, do you think it's possible to, in future iterations of this, like let's say, for example, my dream would be that we hire an army, not a huge army, but a small army of undergrads that could build versions of this in modules for various games, and that will be able to continue developing this particular technology. And I'm just curious about, to what extent do you think it's possible for us to build in an additional layer where we could, I'm not sure how you go from video data to meaningful cluster of keystrokes that represents, for example, taking down the tower, right? Or some sort of meaningful event that is not, am I making sense here? There's like this mezzanine level that goes from the game and what you can actually parse is when you're watching it versus the keystroke data. And that mezzanine level is really the place that you want to be as the researcher, right? So that you could actually look and see a list with timestamps of meaningful units of analysis that are clustered up from keystroke alone. And I don't know whether or not that's a technical, whether it's feasible or not, right? And I just want to hear what you have to say about that, because I know you've worked on this problem for all these months.
I'll be honest, I'm not sure either if that's feasible or not.
Yeah.
But it does sound interesting, and like I think it's something that we could probably explore further because we do have all the keystrokes and we do have the video too. So
And I
just
wonder if
finding
we
a
could
way.
find patterns in those keystrokes of what clusters, so we know when someone is executing a routine of activity. You know, like I play a support character when I play, and I'm horrible at it. But, you know, you have routines that you go through. I mean, there's certain actions that you do repetitively over and over and over. That's why people can write macros for them. So I'd be interested in, and I'm looking at my other students here, Jason, JSOC, and others who are listening in on your defense. I think it would be really exciting to see how far we could get with that. I have to say though, the work that you've done, you know, our adage open source version from 5 or 6 years ago, what you have built is so much more nimble and useful than what we had constructed. So I really just want to commend you on what you've built. It has been really incredibly useful for us. So thank you for that.
Thanks. That means a
Yeah.
lot.
So just to follow up on what you just said, Constance, and then I'll give it to John because I think he wants to follow up as well. Right? I think there's another master's thesis in just that very question, right? Is how do you go from this level of all keystrokes to a meaningful way of querying it? And that's not even talking about the videos, but there's some sort of query thing that needs to happen that needs to elevate the level with which I can issue the queries. That I don't know what that looks like, but it would be really fun to think about. John.
Yeah.
Yeah, so I think so. First of all, Daniel, it's it's amazing to see how far you've come. Since you walked into my office and we said, "Oh, this League of Legends thing would be interesting to study."
Yeah.
So, you know, I this is, you know, most of this is out of my area of knowledge here, but I mean, a couple things, maybe comments / questions, and the first one actually goes to the dialogue that Andre and Constance just had started. Is that I think you actually did a little bit of this when we talked about that sequence analysis using the algorithm that the DNA sequencing, people interested in DNA sequencing use. Helped us uncover these sequences of, you know, actions, which I assume could also be keystrokes, or, you know, a version of that could be made. So you're not giving yourself enough credit, because I think there are possibilities there where somehow you could incorporate that algorithm, you know, I guess you know, middleware, right? I guess is the word everybody's using, that would take these keystrokes and then, you know, do sequence mapping, or you know, some sort of machine learning algorithm that would look for patterns in the data. It would seem, you know, again, I think you did a little bit of this, or am I wrong? Is that something slightly different?
No, yeah, you're definitely right. Like, because that is something that like we've explored together. And for the people that don't know, what I worked with John is that we looked at professional players, and we looked at the sequence of actions that they made, and we applied this algorithm for DNA sequence matching to find these common patterns that keep occurring, to kind of figure out what are these strategies that players, or what are these things that players keep doing over and over again. So I guess that is something that we can employ, like especially with machine learning, to kind of find those things.
I mean, it could be low-hanging fruit to get started, right, on a few of those. The other question I have is, so we did work on the professional leagues data, and I'm wondering, what is the flexibility of this, of, you know, for example, incorporating, you know, unofficial APIs, incorporating different sources, things like that. I mean, do you have to, what kind of access do you really need to get to, like, if you're collecting secondary data, or is this primarily, you know, primary data only kind of action?
So we want to be able to support that type of secondary data, but this tool mainly collects like the primary data. So this includes data CapturEsports includes data that's at a much higher detail than the data that we can get from an API, because we're not able to get when abilities are used or keystrokes from an API.
Got it. Okay. Well, I don't have any other questions. I think it's great. I think I'll echo the committee that, you know, this is a great start. There's a lot of potential. If you do start selling it, make sure it's free for academics.
I will. Thank
Jim.
you.
Yeah, I wanted to follow on with Constance's mezzanine. I really like the terminology, the mezzanine level of like information there. It ties into what my next question. I think it relates. So, you know, you used an example in your thesis about you know, how a player can be hiding behind a bush and just staying still because they're actually waiting to ambush the enemy or something like that. But I might be wrong about the details, something like that. I've never played League, so I don't know if that's, but it's something like that. It was something like an inactivity doesn't mean that a player isn't consciously making decisions. It's just that the decision is to stay there, but it's for a purpose. And you to label something like an ambush, you would need to like look at, you know, all of the players and their like in the terrain and like all their locations from each team, and then see what happens. Right now you have key logs and things like that, but you can't say ambush. You can't label something ambush.
Right.
But you know, the other thing is too, you talked about in your thesis about some of the not competitive tools, but the existing tools that are already out there. And one of them, I don't remember the name, it used machine learning to do this kind of higher level mapping and labeling of things. Is that correct?
Yeah.
So could someone build that machine learning tool on top of your data? Like, are they capturing everything that you're capturing, or can they capture, would you need to capture more to build that kind of layer of machine learning on top?
So we're actually capturing more than what they're doing, that tool is doing. So we can actually apply machine learning to the data that we collect. We just don't have enough yet. But yeah, because the other tool, they were using data from an API, and we have more data than the API.
Cool.
Yeah.
That's all of my questions.
Cool, thank you.
I got one more, which is, were you the blue or the green player?
I could be the bottom player. I don't really know.
Fair enough. Fair enough.
Yeah, the first thing I asked him, Andre, when he walked into my office, well, how good are you at League? And
right.
I think he said, not very.
Yep.
No, he said, I'm okay.
I'm right in the middle.
Not bad, not bad. Anybody from the audience, any questions? Okay, that's quiet. So I think what we'll do is the four of us need to confer, which I actually have not done this before, and I started thinking about how do we do this. I think you just got to stop recording for a minute and put the four of us in a breakout room.
Ooh. Thank you so much.
Yes, and now for the committee, make sure that you do this part again. And everybody should look at the left hand. Yes. That did happen along the way.
What happened?
Oh, I was typing my thesis too much. I'm joking. I'm joking. I was rollerblading and I tripped and fell because I was being a little dumb. So I fractured one of my bones, but it's fine. I'm getting it off in like 3 days, so it should be good.
Yep. So, but
Wow.
yeah, congratulations. Everybody's
so
super
much.
happy. Super happy. Do think carefully what you do next, both in terms of career and with the infrastructure. You know, you might even think about talking to the Overwool folks and saying, look, it works. It's not 100% polished, but it would make your tool a lot more powerful. How would you feel about talking? Right? I think there's opportunities like that. So
Cool.
Yep.
Yeah, I'll definitely think about that.
And I can help you craft the message to them as necessary.
Yeah, that would be great.
So the last bit I think for us is paperwork, and you
Mhm.
inquired how to do that.
So
So educate us, please.
Julie mentioned that you guys should have gotten a DocuSign after today's presentation, but I can email her again to like figure that out. But
Okay,
be on the lookout for a DocuSign coming into your email.
sure. What if I let her know that you passed? That sounds
That
like
could
a
work
good
too.
thing, right?
Yeah.
that should do. So yeah, that's
Awesome.
it. Thank you
Great.
everybody for hanging out with us and taking time out of your day. Thank you on the committee for spending time reading and going from there. And please keep us posted, Daniel. This is great, and don't let this be the last time that we see you, especially over Zoom. It's kind of
Yeah.
sad. Once this thing is
Yeah.
over, we might have to cheers one in person with
Cool.
everybody.
Yeah, definitely. Hopefully, like once they come out with a vaccine.
Yeah,
Uh,
something like that. That's right. So yeah, that's it from my part.
Awesome. Thank you so much, everyone.
Yep. This is the anticlimactic part where you sort of don't even get to hang out. I'll hang out with you for a minute, but the others should feel free to go.
Yeah.
Congratulations.
Yep.
Thank you.
Congratulations.
See ya.
See you, everyone.
There you go, Daniel.
Oh, quite a journey.
Quite a journey. That's that's all we talked about actually in the breakout room. So that's all we
Mhm.
really said is from the moment you walked into to where you are now, it's pretty awesome. That's one of the reasons why we like being at the university and guiding students like yourself and
Mhm.
taking somebody and saying, all right, you're not sure about that, neither are we, but let's get to the other end and see how it goes. And it came out really, really great. So yeah, awesome.
Thank you. Yeah, it was
So
definitely like I definitely remember the struggle of just trying to find someone, like talking to each professor saying like, how does this sound or how does this sound? And then like finally reaching your office and being like, you're like, that sounds cool. Like that.
well, others said that sounds cool too. They just weren't quite ready to go. That sounds cool.
Mhm.
I know nothing about it. Let's write a thesis.
Yeah.
But that's what we do sometimes. And I knew John and I knew Constance and I knew that they'd put their faith in you, and if they do that, you must be a good guy. And that turned out to be very, very true. So I'm just super happy. Super
Yeah,
happy.
me too.
So I don't believe you have any modifications to make to the thesis either, by the way, which is a rarity.
Wow.
So you can bring it to the library in final formatted form,
Hmm.
and then we kick off the signature fest, and that's it.
Yeah, I was actually just about to submit in like right after this
Right.
presentation. So
Perfect. Perfect. Yes.
yeah,
I'd only one comment. Did you have to put on a sweater on a 92-degree day?
no, but I thought it looked better, and now I'm like really sweating, so I'm ready to take it off.
You make the right call, but yes.
I thought it looked nice,
So
but
yes, it did. It did. So go celebrate,
hmm.
and definitely don't be a stranger. You know how to reach me on
Hmm.
Slack. Um,
Definitely.
let me know when as you said, you want to spend a little bit of time supporting the students. You want to take a little break before doing the job hunting part.
Yeah.
But I'm always available to talk, right? And a letter of recommendation is a given. You'll get that from me. You'll get that from Constance. You'll get that
Thank
from
you.
John. Um, but also as you need introductions, or if there's a particular company that may be hiring, blah 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 blah. Let me know. I might know, I might not know, but if I can lend a hand, that would be great.
Thank you. That actually means a lot.
You've
And
earned
like,
it.
thank you so much for helping me throughout the past year and a half. Like, it's been a struggle, but like you've been like guiding me with like such like I don't know, like this wisdom. Like
The
just
wisdom
just
of an
going
old man.
just going through my thesis and like phrasing it, I'm like, wow, I wish like I could phrase things that like eloquently.
Yep.
So just thank you so much for helping me.
Just keep in mind that just means I've seen many, many more theses and I've done this so many times. But no, it's a pleasure. It was, look, this was great work. And it all starts with that, right? If it's interesting, somebody's motivated, there's an interesting problem to address, there's a lot of potential and other interest in the results, it makes it so much easier to word things and to see the path. And you did a great job explaining where you wanted to go. I just had to every once in a while nudge the wording a little bit. Boo. Not a big deal. Not a big
Yeah.
deal. So congratulations also to your family.
Thank
And
you.
you should get on with them and celebrate.
Yeah, I don't know what I'm gonna do, like go to In-N-Out or something. I don't know.
You know, whatever feels right. In-N-Out has been the place where many have gone before to do exactly what you would be doing. So definitely
Mhm.
all good.
All right.
All right.
Uh,
So I will send an email to Julie. We'll go from there. Major congratulations. It's been a real
Thank you.
pleasure.
Thank you so
Yes.
much. I'll
Shake
definitely
hands.
keep in contact.
Yes, we will. See ya.
All right. See ya.
Bye.